All right, guys. So you have the ratio and relationships reasoning worksheet and it says homework, but don't worry about that. And we are going to take a look at this. I want to show you how to operate these problems using proportions. It does say use any method to solve. And later I'll show you more methods, but let's work on proportional reasoning. So remember that a proportion is when you set two ratios equal to each other. So let's look at this problem. It says to make light blue paint, you mix 3 gallons of white paint for every 4 gallons of blue paint, a ratio of 3 to 4. How many gallons of white paint will you need for 20 gallons of blue paint? So let's first go ahead and get our ratio of 3 to 4 written down. And I like to go ahead and label this because I don't want to make the mistake of mixing up my ratios. Remember that order matters. So 4 gallons of blue, so I'm going to write blue down here, and 3 gallons of white. So I'm labeling this part of my ratio. So now we're setting this equal. And let's see, the problem says how many gallons of white paint will you need? So that means we don't know how many gallons of white paint. So I'm just going to put a question mark there. And then it says for 20 gallons of blue paint. So I'm going to put 20 down there at the bottom. Okay, so now let me show you a strategy here. I like to point to what I don't know and point my arrow in the same direction for the other part of my ratio. So now I can look at this and say, how am I going from 4 over to 20? How am I making that jump, guys? And that's by multiplying by 5. So if I multiply by 5 for this part of the ratio, that means up here in the numerator, I also need to multiply by 5. And I know that 3 times 5 is 15. So how many gallons of white paint will you need for 20 gallons of blue paint? You will need 15 gallons. All right, so let's go to the next one. Anita collects shells and rocks in a ratio of 1 to 2, 1 shell to 2 rocks. If she has a total of 8 shells, how many stones does she have? So they wrote stones here, but we know that they're talking about rocks, right? So I'm going to write rocks under this word stones there. So let's start with our ratio. We have a ratio of 1 to 2. And remember that this is 1 shell to 2 rocks. And so now I'm going to make sure I set it equal. And it says 8 shells. So where shells is, I'm going to make sure I'm comparing shells. And I do not yet know how many rocks or stones that she has. So now I'm going to point my arrow to what I don't know. And let me change the color so that you guys can see that a little better. And point my arrow up here in the same direction. So how am I going from 1 to 8? Well, I know that that's by multiplying by 8. So that means down here in the denominator, I need to also multiply by 8. And 2 times 8 is 16. So how many stones does she have, or rocks? 16 rocks. All right, guys, so that is our proportional reasoning we have set up. I have a little bit of background noise, but don't worry, guys, I'm not at home. So I am going to continue. So this was our success starter. So now let's go ahead and let's talk about our equivalent ratios. I'm going. All right, guys. So now we're going to talk about equivalent ratio tables. Equivalent ratio tables. So let's look at this. It says complete the following ratio tables. And I want you guys to kind of think of this like a brain teaser, okay? Like a brain teaser. So some of these are completed, and as we see, some of them are not. And I'm going to go over these first 4 with you guys to show you how to do them. So they show us here is 2 to 6. So I want you to think of the ratio as 2 to 6. So I have to try to use the information they did give me in order to fill in the rest of this information. And we are just using our proportional reasoning here, guys. All right. So, for example, I want to see where I have some information that can help me get to the other numbers. Well, I see that I have a relationship here between these two numbers, 3 and 6. So I'm going to start off by pointing to this box because I don't know what it is and pointing in the same direction. So how am I going from 6 down to 3? Well, that means dividing by 2. So that means up here, I'm also going to divide by 2, and 2 divided by 2 is 1. So now I have figured out that box there for my ratio table. So now let's look at another one. I have a relationship between 3 and 9. So I don't know this one here, and that's okay, but I do know how to get from 3 to 9 by multiplying by 3. So that means I'm going to take my numerator here and also multiply by 3. And 1 times 3 is 3. Okay, so let's look at this next one. I see that I have where we are going from, let's see, 9 to 18. That's by multiplying by 2. So I'm going to take the numerator here for this ratio and also multiply by 2. 3 times 2 is 6. So now I have filled in my entire ratio table. And sometimes they are going to be very tricky. Like, excuse me, guys. Let's look at this next one, 18 to 72. And let's see, if I try to find a relationship between 15 and 18, not an easy jump between those. 10 and 18, not an easy jump between those. 72 and 80, not an easy jump between those either. So that means what I'm going to do is I'm going to reduce this ratio of 18 to 72 to see if that helps me any. Well, then I'm going to ask myself, what is the greatest common factor between 18 and 72? So that means what is the largest number that can go into 18, that can divide up 18, and it divides up 72? And here's the cool thing is that I know that 18 can go into 72. So that means 18 is the greatest common factor. Well, how many 18s am I getting out of 18? 1. How many 18s am I getting out of 72? 4. So now I can use this reduced ratio to easily now find fill in the rest of these boxes. Let me show you what I mean. So if I'm going from 1 to 15, that's by multiplying by 15. So to find out this denominator box, I have to go from that 4 and multiply by 15, and that gives me 60. And I could do this same thing over here to this 10. I'm going from 1 over to 10 by multiplying by 10. So now I'm going to go from this 4 over to this box by also multiplying by 10. So I know that this is 40. And you may notice that these are all going to be equivalent ratios to 1 to 4. 1 to 4, 1 to 4. So let's see. If I'm going from 4 to 80, I'm multiplying by 20. So that means I need to multiply this 1 by 20 to fill in this box. So now I have completed this ratio table. Let's look at another one. All right, so I can't make an easy jump for 12 to 100, but that's okay. But I can make an easy jump between this 15 to 60. I could go from Let's see. So I don't know this numerator, right? So I'm going to point my arrow to this numerator and point my arrow in the same direction here from the denominators. So going from 60 down to 15 is by dividing by 4. So that means up here, my numerator, I also need to divide by 4. And 12 divided by 4 is 3. All right, so I filled in that box. So now let's see what I could do next. I see that I have my numerator missing here, but I have a denominator. And guess what? This denominator has a very good relationship, 20 and 60. So I'm going to go from this numerator box pointing to here because I don't know what's going on there. I have no number in this box, but I'm going to point for my denominators from 20 for 60 to 20. And I know I go down from 60 down to 20 by dividing by 3. So that means up here in the numerator, I need to take that 12 and divide by 3. And 12 divided by 3 is 4. All right. So now I have some more information that I can use to get to this empty box here because I have a relationship between 4 and 100. I could go from 4 to 100 by multiplying by 25. So that means that down here in my denominator, I also have to multiply by 25. You guys see that? So 25 times 20 is 500. All right, let's do one more. Here it is again, where I don't have a good easy jump from 30 and 20 or 18 and 20 or 6 and 20. And all of these are blank, so I can't make a jump from 10 over. So I'm going to reduce this ratio. 10 and 20, the greatest common factor is 10. Get 1 10 out of 10 and 2 10s out of 20. So now I'm going to make this jump. From 2 to 18, I multiply by 9. So I have to multiply this 1 times 9, and I get 9. All right, let's look. From 2 to 6, I multiply by 3. So I'm going to multiply my numerator by 3. 1 times 3 is 3. From 2 to 30, I am multiplying by 15. So I need to multiply my numerator by 15. 1 times 15 is 15. And notice these all reduce to 1 to 2 ratios. So these are all equivalent to each other. All right, guys, so I hope this helped. Please go ahead and finish the rest of this worksheet. You are going to turn it in. And on the back end of this, you're doing the same thing that I just showed you. All right, I hope this helped.